In this session, we're going to discuss critical path analysis. There's an adage that says, if you don't know where you're going, any road will get you there. Well, this is the essence of critical path analysis. By using a critical path analysis, we are now going to start looking at work over time and how one piece of work can depend upon another. We are going to develop a roadmap for our projects. The essential technique for using this critical path method is to construct a model of the project that includes the following: a list of all activities required to complete the project. Typically, these are categorized within a work breakdown structure. The time or duration that each activity will take to completion. And dependencies, in other words, the dependencies between these activities. The critical path analysis, or now critical path method, calculates the longest path of planned activities to the end of the project, which is the earliest and the latest each activity can start and finish without making the project longer. This process determines which activities are critical. In project management, a critical path is the sequence of project network activities which add up to the longest overall duration. This determines the shortest time possible to complete the project. Any delay of an activity on the critical path directly impacts the planned project completion date. A project can have several parallel or near critical paths. An additional parallel path through the network with the total durations that are shorter than the critical path are called subcritical or non-critical paths. One of the ways to look at work over time is with a Gantt chart. This one was produced with Microsoft Project. One of the main uses of this type of project management software is that you can enter data just one time and use it many different ways. As you can see, there are 9 tasks involved in this project listed as A through I, with each task having a duration of days. All you need to do is list the starting point for each task, and the chart that is produced shows you graphically all of the work over time for the project. However, a more powerful tool to use is called the critical path method. This critical path method is a network diagramming technique used to predict the total project duration. A critical path for a project is the series of activities that determine the earliest time by which the project can be completed. It is the longest path through the network diagram and has the least amount of slack or float. Slack or float mean delays. In other words, it's the amount of time an activity may be delayed without delaying a succeeding activity or the project finish date. The longest path containing the critical task is what is driving the completion date for the project. Let's look at this same data as was shown in the Gantt chart previously using the critical path method. Here is the critical path for a particular project. The circles are called nodes and are simply the starting or end points and activity junctions. Here's the associated Gantt chart listing the activities A through I. You will notice that from the starting point of the project, node 1, there are 2 activities whose duration are 10 and 5 days respectively. You can see each one of the activities are listed in the critical path method, but with the added information of dependencies. Activity H depends on activities F's completion. Activity F depends on activity D's completion, and activity D depends on activities A completion. This is what is meant by dependencies of the activities, and all of the paths work this way. Let's look at some of the actual paths of the workflow. Path 1 goes from node 1, the start of the project, through node 2, 4, and 5, and then to node 7, the end of the project. The actual work activities are A, D, F, and H, with the path having a length of 27 days. Now let's look at the longest path. It's path 3. It follows nodes 1, 2, 3, 4, 5, and then 7. The work activities are A, C, E, F, and H. Adding all the durations of these activities, the duration of this path is 37 days. So the critical path shows the shortest time in which a project can be completed, which is the longest path. If one or more of the activities on the critical path takes longer than planned, the whole project will slip unless the project manager takes corrective action. This is where the power of this particular tool comes into play. It is important to know what the critical path throughout the life of the project is so that the project manager can make trade-offs. If one or more of the tasks is behind schedule, the schedule could be renegotiated with the stakeholders, or should more resources be allocated to other items on the critical path to make up for that time. It is also common for project stakeholders to want to shorten project schedule estimates, so you need to know what the tasks are on that critical path. So the project manager can make trade-offs to keep from becoming behind schedule, and then allocate between dependencies if they need to shorten project estimates. Let's look at the steps in creating your critical path for your project. First, specify the individual activities. From the work breakdown structure, a listing can be made of all the activities in the project. This listing can be used as the basis for adding sequence and duration information in later steps. Determine the sequence of those activities. Some activities are dependent upon the completion of others. A listing of the immediate dependencies of each activity is useful for constructing the critical path method network diagram. Draw a network diagram. Once the activities and their sequencing have been defined, the critical path method diagram can now be drawn. You now estimate the completion time for each activity. The time required to complete each activity can be estimated using past experience or the estimates of knowledgeable persons. The critical path method is a deterministic model that does not take into account variation in completion time, so only one number is used for an activity's estimate. And now you identify the critical path, which is the longest path through the network. The significance of the critical path is that the activities that lie on it cannot be delayed without delaying the project. Because of its impact on the entire project, critical path analysis is an important aspect of project planning. You'll update the critical path method diagram as the project progresses. As the project progresses, the actual task completion times will be shown, and the network diagram can be updated to include this information. A new critical path may emerge, and structural changes may be made in the network if the project requirements change.